Hi everyone, so we are going to be looking at D.6, which is the last SL section for the options. And in this topic, we'll be looking at the environmental wastes from the medicinal industry. So previously, pharmacologically active compounds called PACs, these were usually released in the environment because they were not treated as being potentially toxic. So people ignore the fact that this could have consequences on the environment or on different organisms. Now, it has been shown that long-term exposures to PACs has resulted in significant changes in the metabolism and behavior of different organisms. So, for example, when there is unmonitored release of antibiotics in the environment, so for example, if antibiotics are flushed down a toilet or thrown in the garbage, they can enter the water supply or they can leach into the soil. And they get in contact with bacteria in the environment. And when bacteria are exposed to small doses of these PACs, they become resistant. So some of these wastes interfere with bacterial resistance, leading to bacteria that are becoming stronger. Moreover, some of these wastes interfere with the hormone system and increase the risk of cancer or reproductive disorders. Another type of environmental pollutant is radioactive materials, and these materials are used in medical treatment. Now, because these materials have very low radioactivity, they are not treated as being dangerous. Therefore, they are disposed as common waste. However, these radioactive materials eventually they add up to the radiation level of the ecosystem. Therefore, these medical waste they affect the environment. So let's see each of these medical waste. Let's look at the first type of medicinal waste, which is antibiotic waste. Antibiotic waste are produced when antibiotics are released into the environment. Antibiotics are normally used to treat bacterial infections, and antibiotic resistance occurs when bacteria are able to resist the effect of the antibiotic, which means that whatever treatment was traditionally used against the bacteria becomes ineffective, which means that scientists have to create new drugs to fight the same bacteria. But when the bacteria evolve, when they become more resistant, it becomes more and more difficult to create new drugs. So you can see the percentage resistance increasing here over the years for these different types of bacteria. And you can see MRSA. This is called a superbug. So it has evolved over the years, and its percentage resistance is extremely high, which means that it becomes very difficult to treat this bacteria. And normally the doctors would use specific antibiotics because these superbugs are usually resistant to most of the antibiotics available. Now let's see how antibiotic resistance occurs. So when the bacteria is exposed to low levels of antibiotics, some of them will die, but those that survive mutate and are able to tolerate higher concentrations of the drug. So if the cycle goes on, we end up with more and more strong bacteria strains. These bacteria pass their resistance to new generations, replacing the non-resistant strains. So the non-resistant bacteria will die out due to exposure of the level of antibiotic, but most of them that survive, will mutate, and will be able to tolerate high concentrations of the drug. Causes of antibiotic resistance: you have overprescription of antibiotics. So when people take antibiotics for a lot of any time that they are sick, they just constantly take antibiotics. There's non-compliance of patients to finish a course of treatment. Normally an antibiotic treatment course lasts for 3 to 5 days, but when the person starts feeling better after 2 days or 3 days, they stop taking the course, which means that the resistant strains of the bacteria survive. And there's also antibiotics released into the environment. In animal feeds, healthy animals are given antibiotics to prevent livestock diseases, and this is eventually consumed by humans in the form of dairy products or meat. So meat, dairy products that we eat contain traces of antibiotics. There's improper disposal of antibiotic medicine by hospitals and households. So for example, if you flush it down the toilet or you throw it from the bin. There's antibiotics in agricultural waste, such as manure and water runoff, which can carry antibiotics into the soil and underground. Also, antibiotics excreted by humans in urine and pharmaceutical waste that enter the sewage system at low concentrations. Sewage treatment plants are rarely equipped to remove antibiotics from wastewater, and hence, when sewage water is treated, the antibiotic usually ends up in the drinking water. So you have a little picture that shows the source of antibiotics into our environment. So homes and hospitals, they will produce antibiotic waste. You have pharmaceutical company that produce chemical waste. You have farms that use antibiotics to keep the animals healthy. So all these antibiotic waste end up in the water. Water goes into the water treatment plant, but the water treatment plant is not equipped to remove antibiotics from the water that it's treating. So some of these antibiotics end up into the water that we are drinking. Now, the use of antibiotics as growth promoters was banned in the late 1990s. So, growth promoters are actually antibiotics that are administered at low subtherapeutic doses, so very low doses of antibiotics that are administered to the farm animals, to the livestock, and it helps the livestock to grow and to prevent them from being infected. But when this was banned in the late 1990s, it resulted in the death and disease of animals. And this increase in death of the animals was because the antibiotics had already weakened the immune system of animals and human beings, which means that when the antibiotics stopped being administered, it led them to be very susceptible to infections. There are several ways to prevent the development of antibiotic resistance. First is restricting the use of antibiotic treatment only to severe cases of antibacterial infections. If you go to the doctor and you have been sick and you are suspecting that you have a bacterial infection, the doctor will ensure that you have been sick for at least 3 days before prescribing an antibiotic. So this is what they are doing. They're restricting antibiotic treatment to severe cases. Second is banning non-medical use of antibiotic, which means that we're not prescribing antibiotics anymore as a preventive measure. There's also reducing amount of antibiotic waste from hospital and pharmaceutical industry by waste processing before these are released into the environment, and also producing and using new antibiotics under strict control. So this prevents new strains or strong bacteria from evolving from these new antibiotics.